This is the third video in a series on 2D motion where you put together simple 2D vectors. Like you have these two vectors right here and they become components, the y component and the x component, and you put them together and you get this one. That's the graphical representation, but we're going to go ahead and do that with numbers. So here's an example where Samantha walks 27 meters north and draw a dot. She went 27 meters north and she followed that with 15 meters west. And now what's her displacement from the origin? Go ahead and draw where she's going to go. So where is she from the start? That's the arrow that represents it. And draw theta to represent where the angle is going to be, because we're going to describe this right here, this line. So we're going to be going at this angle from this line right here. So now that we have that, we have this theta that we're trying to describe opens up to the opposite. We have our other side, which is our adjacent. And we have C, which we're interested in. Or this, I guess, this resultant part. I'm just used to A, B, and C for Pythagorean theorem, which of course you see right there. So to solve for C, that rearranges to A squared plus B squared. When you want to break away the squared, we take the square root of it. So square root of, make sure you have this in parentheses, A, which is 15 squared, plus B, which is 27 squared. And when you type that into the calculator, you have 15 squared plus 27 squared equals 954, but that's not our answer. Take the square root of that, and we get 30.88. I'm just going to say 30.9 meters, or 31. You can say 31 if you're going with sig figs. 30.9 meters. And now we need to finish off the next step to our direction. We need to figure out this angle. So we found the side right here. Now we have to find this angle. To find the angle, we're going to go ahead and we have opposite and we have adjacent. So that's going to lead us to this. But in order to break away the tangent from that angle, I have to take the inverse tangent. Looks like that of both sides. And so when I take the inverse tangent of both sides, this tangent is going to be left off, and I can solve for the angle. So angle equals, and this is a theta, theta equals inverse tangent. And most calculators have this right above the tangent as like a second button or a shift button. Opposite, which is 15, over adjacent, which is 27. And we take the inverse tangent of that. Now, watch out when you're typing in sine, cosine, tangent, or inverse of anything. Make sure your calculators are in degrees, or else your answer here is going to be different than mine. And if you're wondering why it is, go back and check your memory, or your mode, to see if your mode is in degrees. And inverse tangent of 15 over 27 is 29.05. So let's go ahead and say 29 degrees. So that right there is 29 degrees. And now our final description of this. For our final description, we want to have a magnitude. For this to be correct, we want to have an angle, which we've solved for both of these. Then we want a description of that angle. So we're going to describe that angle. So our magnitude, we found that out to be 30.9 meters. We found our angle to be 29 degrees. Once again, remember magnitude is the number and the unit. The angle is 29 degrees. And now we have to do the description. Well, here we are going to the west of north. And if you keep on coming up with the description the wrong way, the way I say to do it is to go ahead and draw it. If you're good at the last lesson, go ahead and draw what you don't look at what you drew here. So don't ignore this right here. Just go ahead and look at this and go ahead and draw it backwards. North first, west second, then fill it in and draw the angle right here. And if this matches that, which it does here, you know that your description was right. So this is the total answer for a question like this.